This video is sponsored by Brilliant. Hey guys, this looks like a fun one. We're given two equilateral triangles inside of a square. The area of the larger equilateral triangle is 12, and it wants to know what is the area of the smaller equilateral triangle. If you want to try it on your own, pause it right now, because I'm going to solve it in 3, 2, 1. First, let's isolate the two equilateral triangles, and let's line them up next to each other. Since these two triangles are similar figures and we're interested in the areas, let's use these notes here. They tell us the relationships of the areas of similar figures. Let's call the side length of this triangle A and the side length of this triangle B. The scale factor between this triangle and this triangle is A to B, and the area ratio is A squared to B squared. With these notes, we can set up a proportion. It'll be this area 12 over this area question mark equals A squared over B squared. I'm pretty sure we can use this proportion to solve it. In fact, if you're hearing this sentence right now, that means we ended up using this proportion to solve it. So this must be important. Let's put a box around it. Now let's bring ourselves back to here. Now we're back where we started, but we have the larger triangle has a side length of A and the smaller triangle has a side length of B. Since this is a square, this side length is also going to be A. And since this is an equilateral triangle, this side is also going to be B. Next, let's talk about angles. Inside of a square, all the angles are right angles. And in equilateral triangles, all the angles are equal to 60 degrees. So this angle here will be 60 degrees, and this angle here will be 60 degrees. Since these were both 90 degrees, that leaves 30 degrees here and 30 degrees here. And on the right-hand side here, we have a very nice isosceles triangle. And since both these angles are equal to 30 degrees, this side is also equal to B. And now we got to figure out a relationship between B and A. Let's draw the altitude here, which will be at right angles. And in an isosceles triangle, the altitude is also the perpendicular bisector. So this base of A is going to be split even between these two sides. They're each going to be 1/2 of A. And now let's focus on this half of the triangle. This is a 30, 60, 90 triangle. So let's use the notes for 30, 60, 90 triangles. Anytime you go from the medium side length to the shortest side length, you're going to divide by the square root of 3. So this side will be A over 2 divided by root 3, which simplifies to A over 2 root 3. And then to go from the shortest side to the longest side, you end up multiplying by 2. So this side is going to be 2A over 2 root 3. And this 2 on top and bottom can cancel each other out. So we end up with B is equal to A over square root of 3. And this is exactly what we needed. We needed a relationship between B and A. So this was really helpful. We are now done with it though. And let's bring up our notes from before. Since B is equal to A over square root of 3, in the place of this B down here, let's plug in A over square root of 3. And in the denominator, this square can distribute to both of these terms. Let's smush everything together, and this A squared over A squared can both simplify to 1 over 1. And the square root of 3 squared is equal to 3. Now we have 1 divided by 1/3. Anytime you divide by a fraction, that's the same thing as multiplying by the reciprocal. So 1 divided by 1/3 is the same thing as multiplying by 3. And 1 times 3 is 3. So now we have 12 over question mark is equal to 3. So there's a couple ways we can do this. We can cross multiply or other things. I think it'll be fun to rewrite this 3 as a fraction with a 12 on top. Well, that's going to be 12/4. So we can rewrite this as 12 over question mark equals 12 over 4. And that's only going to be true if the question mark is equal to 4. The area of this smaller equilateral triangle is equal to 4. There's no units for the 12, so to be consistent, let's not put units here. This is the answer to our question. Let's put a box around it. How exciting. We used a couple different concepts in this video. We used the areas of similar figures, and we used the side lengths of 30, 60, 90 triangles. If you want to have a deeper understanding of either of these two concepts, Brilliant has you covered. Brilliant has thousands of lessons in math, data analysis, programming, and AI. And all of them are interactive, which is the most effective way to learn. In the geometry course, it was easy to find the lesson on similar figures, and they did an amazing job of explaining how the areas are related to each other. I also like the lesson on 30, 60, 90 triangles. It was cool how they set it all up, and I like how they explained it. You can tell they put a lot of thought and care into the best way of explaining it. And they have that same level of care and quality in all their lessons. To try Brilliant for free, visit brilliant.org/andymath or scan the QR code on the screen. Or you can click on the link in the description. And with that link, you can also get 20% off an annual premium plan. How exciting.